more homework. Homework 1-5. So I left the first three for you to do. I did this one because I had a fraction, and I know kids are scared of fractions. Make this grid a little bigger for myself, easier for you to see it. No, so you're supposed to solve this by graphing and then check algebraically. So the first thing I'm going to do is I'm going to graph the left-hand side here. That's absolute value. It's a right 4, down 4 situation. Right 4, down 4. And we have the understood 1 out front, so the initial slope is 1. And I'm going to put a lot of dots because I'm solving by graphing. And I just want to make sure that I pass through the points that I need to pass through. It looks something like that. Then I have, I really messed that one up. I have 1/2 x, I know kids, I don't know how, but I know a lot of kids struggle with this thing. It's technically 1/2 x plus 0. So I have a y-intercept at the origin, 0, 0, because y is 0. And this is my slope. Rise 1, run 2. I don't know how kids don't understand that by the time they're juniors, but whatever. Rise 1, run 2. Rise 1, run 2. 1, run 2. 1, run 2. 1, run 2. It looks like eventually these would have intersected, doesn't it? There's another answer to this one. There's two. This is one of the reasons why we check algebraically. But obviously there's an intersection at 0, so my solutions here are x equals 0. And there is another one. I can tell because that blue line is going to cross that red line's path. All right, so algebraically, you have to do this whether you want to do it or not. Turns out a 10 by 10 grid just wasn't big enough. We have two equations. The first one is as is. It's x minus 4 and then minus 4 equals 1/2 x. All right. The other one is only change the sign on the stuff inside. Negative x plus 4, then minus 4 equals 1/2 x. Now, what I'm going to do is I'm going to eliminate the fraction. I'm going to distribute a 2 to everything because that gets rid of that fraction. This would be -8, put it together, -16, and then we have 2x. I'm going to shift my x's left, my number's right, and x is 16. So there is another one. This one, by the way, was at 0, 0. And if x is 16, half of that's 8. So the other one is at 16, 8. I knew there was another answer. This equation down here is probably going to give me the 0, 0 answer. Let's see, we have negative x. When we put 4 and 4 together equals 1/2 x. We'll double both sides. 2 times negative x is negative 2x, and that equals x. Shift that over, negative 3x is 0. Divide by the negative 3, and 0 divided by anything is still 0. If you plug a 0 in right there, you get an output of 0. So there you go. Sometimes algebra works better than a grid. All right, you're supposed to do these. And I'll work with the left-hand side first. This is a left 4, down 2. It's going to put me right there. We have a slope of -1, so we're going to fall 1 and run 1 for all of eternity. Again, you're going to want lots of dots. You just don't know where they're going to cross paths. I don't know if you can hear me over the classroom next door who's way too loud. Maybe you can, maybe you can't. And now I'm going to graph the other guy. That is a shift down 8 and left 2. And then left 2. And it has increasing slope. It's got the understood 1 in front. This one has its nice two answers. Looks like we intersect at 0, -8. Most importantly, there's that x is 0, okay? And we intersect at -6, -4. And again, the big deal there is that x is -6. So those are intersections. Solving algebraically, just pick one absolute value. I'm going to work with this one. There's a negative symbol, and then there's an x plus 4 minus 2. And we're just going to leave the other side the way it is. X plus 2 minus 8. Or the negative symbol, and then we change the stuff inside. Sometimes you have to write more equations, but I don't think you do too often. You just change the signs on one of the absolute values and it'll work its way out. If we distribute the negative, we'd have negative x minus 4 minus 2, negative x minus 6. Combining like terms on the other side is x minus 6. Now I'm going to shift my x's right and my numbers left. That's going to get me 0 equals what? 2x? Divide by 2, and x is still 0. So that one checked out algebraically. Distributing the negative here, I'm going to have x plus 4, and then minus 2. Combining stuff on the right, I have a negative 6. This is x plus 2 equals x minus 6. Ah, phooey. I didn't make a mistake anywhere, did I? Well, we got a gibberish equation. We did get gibberish, didn't we? Yep, we got gibberish. Yeah, so I was kind of wrong. We're probably going to have to write a third equation. The reason I'm saying there's gibberish is because if we move our x's to one side, we literally have no x. And that is equal to -8, and this is nonsense. So let's keep playing with this guy that we had here. And let's change the signs on that one. Anyways, distributing the negative gives us a positive x. 4 minus 2 is 2. Same thing we had up here. And on the other side, we have negative x minus 10. X is on one side, numbers on the other. We'll put this over here. That'll give us 2x. We'll move that over there. That'll give us -12. And we'll get our x value of -6. Those are the answers. Ta-da! Number 7 is something you haven't done since Algebra 1. There's lots of things we can do on this one. You are required to know the vertex of a quadratic is at opposite b divided by twice a, and that will be called f of opposite b over twice a. That's on your formula quiz, by the way. It is. You are also expected to know how to factor. Find your x-intercepts by letting y equal 0. So we're going to do some work on these things. So the first thing I'm going to do is I'm going to find opposite b over 2a. This is x squared minus 7x minus 8. There's a thing that we call standard form. I call it STD form. And it's ax squared plus bx plus c. And just doing a line-up process with the numbers out front, we get that a is 1, b is -7, and c is -8. So now I can do this opposite b over 2a. The x-coordinate of the vertex, x subscript v, is going to be at opposite of a -7, which is +7, over twice a 1. And that's going to be 7/2. You guys like decimals. Bleh. 3.5. To get the y-coordinate, we plug that back in. So now we're going to find f of 3.5. That's going to be a 3.5 that is squared minus 7 times 3.5 minus 8. And mentally, I'm not here today. So let's push some buttons. I'm going to use the storage feature. Take a 3.5, store it to x. Type in the equation, x to the second minus 7x minus 8. Y value is negative 20.25. So my vertex ended up being at 3.5 and negative 20.25. So to the right 3.5 units, and then down, way down here, kind of a funny spot, I can get the x-intercepts by setting the equation equal to 0, and then doing something we call factoring. That's always fun for kids. It takes an x and an x to make an x squared. It takes a 1 and an 8 to make an 8. We're going to do negative 8 and positive 1 because negative 8 plus 1 is negative 7. And the x-intercepts, we're using the zero product property. X plus 1 is 0, or x minus 8 is 0. That tells me that x is negative 1. Remember things lying about their sign? Or x equals 8. Technically, this is going to be negative 1, 0 and 8, 0. So this parabola has a vertex way, 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 way down here, and then it passes through those points. Now, why did I do all of that math? For a simple reason, because I wanted to know where it was greater than 0. It talks about where is that equation above 0. See that little symbol there? Another way of saying that is, where is this equation positive? You are positive on this tail and that tail. And it's an inequality, and inequalities are answered with inequalities. You are positive so long as x is less than or equal to negative 1. Sorry, not less than or equal to. There's no equality implied here. So long as s is less than negative 1, or x is greater than, what, 8? Now, algebraically is a little bit different. It still takes a bit of work. We start off with what we had originally. We factored it just a few minutes ago. It was x minus 8 and x plus 1. And it was bigger than 0. And we call these critical values here. A critical value is that x is 8, and a critical value is that x is negative 1. And what you do is you put things on a number line. Open hole because I can't be those things. Open hole. And then I test around these values. So I'm going to test something less than negative 1, which is negative 2. I'm going to test in between, which is 0. And then I'm going to test something bigger than 8, which is 9. So what I'm going to do here is I'm going to plug a negative 2 into this equation. Negative 2 squared minus 7 times a negative 2 minus 8 bigger than 0. It should be, because the graph is saying that it's going to be true. This is going to be 4 plus 14 minus 8 bigger than 0, and that is definitely true, because that's a positive number. So this is true. This is saying I can be everything there. All right? If I plug in a 0, I would have 0 minus 8. That's going to be false. because it's saying negative 8 greater than 0. That's false. If I plug in a 9, I'm going to have 9 squared minus 7 times 9 minus 8. And that's 81 minus 63 minus 8 bigger than 0. That is true. So this is true. And that's saying everything to the right. Now, since I've got a number line, I may as well write out the interval. This is negative infinity all the way to negative 1, union with 8 to infinity. There aren't a whole lot of kids that like quadratic inequalities in this world. Not a whole lot of people that like them either. Here's another one. What I'm going to do first on this one is I'm going to divide out the negative 1. And the reason I'm doing it is that makes x squared positive. And it flips the symbol. Maybe you remember that. Maybe Miss Buckley told you to do that. I don't know. When I find the x-coordinate of the vertex, it's at opposite b, which is negative 2 over twice a, which is 2 times 1. So it's a negative 1. Now I'm going to find the y-coordinate of the vertex by taking that negative 1 and plugging it in. That's going to give me 1 minus 2 minus 15, which is negative 16. So this one's on down here a little bit. We're at negative 1, negative 16. It's somewhere down there. I am going to factor that thing. Takes an x and an x to create x squared. Factors of 15 are 3 and 5. The 5 is positive, the 3 is negative because 5 minus 3 is 2. And the x-intercepts are going to be at 3 and negative 5. There is my graph. Now, you're probably like, Milbrath, but there's a negative out front. Yeah, I know. I know what's there. I manipulated it. I changed it because it'd be easier. That tail and that tail matter. Tail here is that we're going to be less than negative 5. And there's equality. Or I'm greater than or equal to 3. Now, the algebraic check is the part that kids don't like. And there's nothing I can do about that. We take our critical values, which were 3 and negative 5. We place them on number line. These get to be solid dots this time because we had equality. And then we test around them. So like I'm going to test to the left, which is a negative 6. I'm going to test in the middle, which is a 0. And I'm going to test to the right of 3, which is a 4. If I plug this negative 6 into this equation up here, I'm going to have 36 minus 12 minus 15. And my new relationship is being bigger than or equal to 0. And that is true. So I get to keep everything left. If I take this 0 and I plug it up here, I have 0 plus 0 minus 15. Negative 15 greater than or equal to 0 is false. So none of this stuff matters. All right? If I plug in a 4, 4 squared is 16. 2 times 4 is 8. 16 plus 8 is 24. 24 minus 15 is 9. 9 greater than or equal to 0. That is true. I keep this stuff over here. It's funny that solving algebraically still involves visualization. Still technically graphing to some degree. But this is telling me negative infinity to negative 5 bracket union with 3 to infinity, which is exactly what this means. It's the same thing, just different notation. There's 9. Here's 12. 12 is a solve with technology problem. So we're going to pull up my old TI-84 here. I'm going to put this into Y1 and this into Y2. We have to view the left-hand side as Y1 and the right-hand side as Y2. The absolute value function on a TI-84, and first off, we're going to Y equals. But absolute value is under math, how a typical teenager feels, which is num, and it's right there along the top, ABS. X plus 2. Arrow out, minus 6. And Y2 is the second function, x to the second, minus 7x, minus 2. And I teach kids to do what's called a zoom 6. So zoom, choose 6. You can actually just hit the 6 key. Solutions happen when two things cross paths. We have an intersection here and an intersection there. Second trace, scroll down to 5. Let's get that cursor close. I'm pressing that right arrow a few times. Notice I didn't hold it. And I'm going to press enter once, twice, thrice. There's an answer. I'll round that in just a minute. You are supposed to round it. Second trace 5 again. I'm going to hold that arrow down this time because I'm going to get close to that second path or intersection, and I'm going to press enter 3 times there. There's another intersection. I think I got just enough time to round these two numbers before the 5th period walks on in here. So anyways, your instructions say round to the 4th decimal. That looks like 0.2583. The other one, 7.7417. It's amazing to me every year how many kids can't round. It's a large number of children who can't round. It's scary. Anyways, that's all I got time for next period, because next period starts at 11:26. And I guess I got something else to do during my lunch break. Later, kids.